Hello again. Today we're going to be graphing logarithmic functions, all right? And we are also told to describe the vertical asymptote and state the domain and range. So let's get started here. When you graph a logarithmic function, it is going to be the inverse of an exponential function, okay? For instance, if I were to graph y equals b to the x power, where b is some number that's greater than 1. For instance, y is equal to 2 to the x power. And if I graphed that and I made my x values -2, -1, 0, 1, and 2, well, that would mean that my y values would be 1/4, 1/2, 1, 2, and 4. So I would graph that and it would look something like this. -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. All right. So that graph, when I connect all the points with the curve, looks something like that. And these, remember, have a horizontal asymptote. And in this case, the horizontal asymptote would be right here at y equals 0. Now, if we were to graph the inverse of this, the inverse of this would be y equals log base b of x. Well, you'll notice that our b for this problem is going to be 2. So I will write y equals log base 2 of x. And what you'll notice is this will be actually a reflection. If you remember symmetry from geometry, this curve is going to be reflected like a mirror image on the other side of this red dotted line. And this one is reflected about the line y equals x, which means that all the x values and the y values will swap. So that means x and y will be 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. So x is 1/4, y is -2. X is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. And when x is 4, y is 2. So I will draw my curve, and you will see that this curve is reflected about our red dotted line. Now, they need us to describe the vertical asymptote. So the vertical asymptote will be the one that goes up and down. And this one looks like the line is approaching x equals 0, which is the y-axis here. So my vertical asymptote is x equals 0. Now we also need to find the domain and range. Well, the domain is whatever x can equal. Well, it looks like on this one, x needs to be greater than 0. So x is greater than 0. And the range, how high or how low can this orange curve go? It looks like it can go on forever. So that means that the range is all real numbers.